Hello everyone. Today I present our research result, that is requirements engineering for autonomous perception system and value study. So we focus on driving automation system. What is driving automation system? Driving automation system include autonomous driving as well as advanced driver assistance system. Why we choose this driving automation system? Because it is one of the most important safety critical domain and often incorporate machine learning to analyze the vehicle environment. Thus, functionality depends on the correctness and integrity of perception systems, which is blended with machine learning with traditional signal processing. And here, perception systems means machine learning-based perception systems in our study. So, what is the background and research gap? Recent research results explored requirements engineering challenges for machine learning systems. However, it is not explored in driving automation systems domain yet. And addressing this gap is necessary for advanced practices in both this domain and in the broader requirements engineering for artificial intelligence or machine learning. And we focus on this domain to get specific challenges, but we are looking more broadly on requirements engineering for artificial intelligence to build a body of knowledge. And we have two research questions here. The first one is, what are the requirements engineering topics of interest for driving automation system? And second one is, what challenges are experienced by practitioners in RE for perception systems, for driving automation systems? So we conducted an interview study. It was a group interview study. We had 19 participants, consisted in 7 groups interviews, and that covers 5 companies who are working with autonomous driving or autonomous solutions. And we collected mostly qualitative data, and we have done deductive and inductive codes for analyzing those data. We used Miro as a tool, and we have done thematic analysis. Then we also arranged a workshop for intermediate validation of our data analysis. So we found 5 broad topics of interest which covers this area, which are operational design domain, and under these big topics we also found some subtopics. So we mostly talk about these broader topics. So first one is operational design domain, then scenarios and edge cases, traceability, requirements breakdown, and requirements specification. So our interviews mostly talk about these topics as well as the challenges while specifying requirements in these topics of interest. So the first topic, operational design domain. So according to the interviews, operational design domain should be captured as a part of requirements specification for driving automation systems. It is critical to deal with operational design domain as required by standards. We have some standards right now, but of those standards doesn't cover the self-perception system yet. So we need a process for specifying and defining operational design domain. Data distribution requirements are highly influenced by the operational design domain where the autonomous vehicle runs. Though operational design domain drive data collection, specifying and collecting certain types of data required by operational design domain still is very difficult. Then scenarios and edge cases. So it is important that perception systems work correctly. As such, scenarios can help in requirements derivation or requirements specification, and testing through scenarios enables iterative requirements refinement. It is crucial and challenging to deal with edge cases, which are rare events in driving autonomous systems. Data from edge cases are often annotated inconsistently because those scenarios doesn't come very frequently in the sim. And how well edge cases are covered can be important development metrics in driving automation system. And interviews stated that collecting data points for particular scenarios for the real world is necessary, but particularly difficult for edge cases. So they focus more on edge cases for the correct annotation and collecting current data from the real world. Then they also talked about requirements breakdown and challenges regarding requirements breakdown. So requirements breakdown involves refining and decomposing requirements. It is connecting high-level requirements to low-level requirements, which is challenging. And traditional requirements breakdown cannot be easily applied, so we need solution on this area. Though linking functional requirements to system accuracy is often possible, breaking functional requirements into data and application requirements is more difficult in this case. It is more challenging when teams collaborate to specify quality requirements. So it is one of the more important focus from the practitioners. Frequent and direct interaction with stakeholders can reduce this challenge, but the communication should be efficient. The breakdown for the machine learning based components is particularly challenging. And due to dependencies between components and volatile nature of machine learning, changes in machine learning model can also drastic change in other parts of the system. Traceability is one of the most challenging topic here. So non-traceability challenges are increased by the use of machine learning and associated data. Tracing the source of the issue is difficult to the combination of machine learning models and traditional code. And it is important that traceability be maintained not just between code and requirement, but also machine learning elements. Then requirement specification. Sometimes clients provide unachievable requirements, which is difficult to address. Documentation of the rationale and goals of the project can serve as a form of requirement specification for driving automation systems. And the uncertain and highly iterative nature of perception system and their development environment means that specifications are particularly prone to change. So requirements can change during the development phase as well. Then specifying data requirements is very difficult for driving automation systems, and it's different from the functional specification, as it is hard to identify features and ensure data quality upfront. It is difficult to specify quality requirements and data annotation for autonomous perception system, and it is difficult to have an upfront and detailed specification for data classes, accuracy level. And the challenges they talked about during the interview. Operational design domain detection and operational design domain execution is challenging. Therefore, requirements specification is challenging because requirement specification is highly dependent on operational design domain. Data requirements are highly influenced by the content of operational design domain. One major challenge is that simulation should reflect realistic scenarios. So though big companies are more moving to simulation-based verification, validation, and so on, but it's difficult to map with realistic scenarios, and it is sometimes acceptable. Edge cases introduce challenges as they create confusion among annotators. So practitioners focused on this. Edge cases are challenging to test in reality due to safety concerns. They also talked about breaking down requirements for data and annotation can be very difficult, and additional challenges introduced due to requirements dependencies because it requires multiple teams to collaborate. Difficulties in breakdown machine learning openness as well as the introduction of more elements to trace, which make more difficult in traceability. Creating specification for data and annotation is challenging, especially for edge cases and rare cases. And sometimes machine learning components are assigned unrealistic and unachievable requirements by the customers as well as different stakeholders. And quantifying quality requirements is challenging in perception systems. So, what is our future work? Sorry. Our study investigates requirements engineering practices and challenges during development of perception systems. Though these work focus on perception systems, we believe that requirements engineering practices and challenges found we apply more generally in other domain, which involves machine learning. And our study suggests future research in we need more empirical studies to understand the generalizability of the topic and challenges, and we need solution to address the challenges I presented. So that's it. Thank you very much for listening.
Thank you. So comments or questions? Habib just defended his licentiate thesis a few weeks ago, right? So
yes.
Yeah.
A small question. I expect more specific recommendations for the requirements. This is still on the big, gives you a vague direction, but I expect it's something more concrete. So why am I wrong?
Yeah, these challenges as well as topics came for autonomous perception system more specifically.
Yeah.
But we can generalize this result for other safety critical systems as well. But we don't have solution yet in this case. So these challenges, we collected these challenges and topics. So we require solution to address these challenges, but we don't have solution yet.
Okay. Then it's good. Okay, thanks.
And it's not a reflection on your work really at all, but is actually requirements engineering and functional safety, is that reconcilable with machine learning based methods? I mean, I question that whole precept, to be honest. So what's your opinion on that? Can we find a merger between requirements engineering where it actually works for perception systems, for instance?
Yeah, like actually my research topic is non-functional requirements or quality requirements for machine learning. So at the beginning of my PhD thesis, we explored more in problem space, what non-functional requirements related challenges we are facing, what requirements engineering related challenges we are facing. So at the beginning, we focused on general machine learning enabled systems, what challenges, requirements engineering related challenges, non-functional requirements related challenges where practitioners are facing. So then we thought that, okay, we can also look for general requirements engineering challenges because non-functional requirement is part of requirements engineering. And we wanted to see specific domain which involves machine learning. So far we are collecting mostly challenges involves requirements engineering process for machine learning enabled systems, and we found the traditional requirements engineering process is not very applicable for machine learning enabled systems because machine learning is a small part of, though machine learning is small part of bigger system, it creates some difficulty because of uncertainty of such systems. It is less explainable, and upfront requirements is not possible to specify because of the opaqueness of the system. So we explore those, like we identified those challenges. So now we started working on more solution space where we incorporate all those problems or challenges we found from the practitioners. But we don't know if like, we found it's not possible traditional requirements engineering to apply in machine learning enabled system, but we don't have solution yet. So we are working on that. We are trying to provide a framework actually now for incorporating specifically non-functional requirements for machine learning enabled systems. So by this study, we identified more general requirements engineering challenges. So hopefully in future we will work more on solution for general requirements engineering cases.
Thank you.
That was a good question.
Actually, I don't see any large problems with that. There is Swedish safety community that's been talking about this for a while now, and there are
Yes.
solutions.
I mean, yes, they're talking about it, but I mean, and I've listened to that discussion for the last decade or so. But I mean, to me, the main thing with machine learning in general is that you have a system that needs to generalize outside of known samples. And functional safety deals only with known samples, essentially. So how can you formally prove something which you don't know, which you even don't know exists in the first place? That's kind of the irreconcilable parts of it, is that the world is very uncertain and weird. And they're trying to codify that weirdness.
Yeah, but on the other hand, I mean, that's from the philosophical standpoint, but from the practical standpoint, you build safety cases around certain things, and then machine learning algorithm, basically like any other algorithm. As long as you don't have to formally prove it, then you can still use it in production systems.
Yeah, the point here is that you can never prove that a system is 100% accurate. So, and then you're in the formal verification space. If you can't prove that it's 100% accurate, how can you deal with when you don't know when it's inaccurate? There's no way to know that.
But even normal algorithms, control algorithms today, most of them that are used in cars, for example, not formally proven.
No, that's true.
So even the ABS system, which is ACD, and that's not formally proven.
No.
So from that practical perspective, what's the difference between?
That's true. I was mainly thinking about formal methods.
Yeah, there I fully agree with you. But